let's look at question 4, where we have two reactions, and we will define extent of reactions using X's for reaction 1 and reaction 2. And we have things of lots of different phases, but basically what I need to know is I'm looking for equations that are of the form Ka for reaction 1 is going to be the activity for D times the activity for C over the activity of A and activity of B. And Ka2 is the activity of E squared over activity of B, activity of D. Okay, so we have that, so we need to figure out what those activities are. And recognizing that we have some solids, some liquids, some gases. So we need to start with mole balances. The number of moles I would have of each species in terms of extent of reaction, well, for species A, it said that we feed 2 moles of A, and it disappears in reaction 1 as minus X1. B started with 1 mole and disappears in reaction 1 and in reaction 2. C will be started with none and appearing in reaction 1. D is starting with 0, appears in reaction 1, disappears in reaction 2. And E is going to appear in reaction 2, but twice the extent of reaction because of the stoichiometric coefficient. Okay, so I have this, but what I need for activity is I'm going to need things about the mole fractions. And some of these are solids and some of these are liquids. So if I looked at the total, when I add these up, this ends up being equimolar. But that's not really the point. I have some of these are liquids and some of these are gases. Now, this is a solid, this is a gas, and B, C, and E are all liquids. So when I add those up, the number of moles that are in the liquid is 1 plus X2. And the amount that is gas is X1 minus X2. So, therefore, Y for A, or X, or whatever you want to call for the mole fraction of this, is just 1, right? The solid is going to be all component A. The gas is all component D. And the liquids, I have X for B, X for C, and X for E, and those are determined by taking the number of moles of the component divided by N of the liquid. So this is 1 minus X1 minus X2 over 1 plus X2. This one is X1 over 1 plus X2. And the last one is 2X2 over 1 plus X2. But of course, what's really required is activity. So activity of a solid, so component A, is always 1. Activity for a liquid is going to be the X times the activity coefficient. So gamma B, 1 minus X1 minus X2 over 1 plus X2. Activity for C, another liquid, is gamma C X1 over 1 plus X2. And activity for E, my third liquid, is 2 gamma E X2 over 1 plus X2. Now what about my gas? Well, my gas is going to be Y times the pressure over 1 bar if I'm assuming modest pressures. So the mole fraction Y is 1. The pressure is given as 3 bar divided by 1 bar, and so the activity for D is equal to 3. and we can then substitute those in and get equations to solve. So in this particular case, for the reaction 1, the denominators 1 plus x2 cancel out. We end up with 3 gamma c x1 over gamma b 1 minus x1 minus x2. And for the other equation, we have 0.5, the KB or K2 value is 4 gamma E squared x2 squared over 1 plus x2 squared over 3 gamma B 1 minus x1 minus x2 over 1 plus x2 squared, and we can simplify that slightly as this expression here. So one of the 1 plus x2's cancels top and bottom. So that concludes question 4 from our exam. Thank you very much for your time.